Hello everyone, welcome to another short video. In this video, we are going to look at tunnel inspection policy on Palo Alto firewall. So I'm going to demonstrate basically tunnel inspection policies using this topology. Let me explain you the topology quickly. So there are two routers, R3 and R4. They have a GRE tunnel between them. There is a GRE tunnel that runs through the Palo Alto firewall and is created on R3 and R4. My firewall is not a termination point for that tunnel. It's just in between of the tunnel. Okay. So the tunnels are terminated on R3 and R4. Now, let me just start them up. There are two VPCs, VPC5 and VPC6 on these respective IP addresses, and these subnets 172.16.20.0/24 has been routed from this router in the GRE tunnel tunnel 10, and from this router 10.08 routed to the GRE tunnel 10. So in short, any traffic for these subnets coming on these routers will be going to the GRE tunnel, okay, and not on the link which they have. Now, um, yeah, I have also written the same in here, GRE tunnel between R3 and R4, subnet this and this, communicate via GRE tunnel. So firewall cannot see it because that's inside the tunnel. And the tunnel inspection policy is the mechanism that we use in order for firewall to look inside the tunnel. So firewall can look inside the tunnel and look at these subnets as well. Now, let's jump onto the firewall and see how the things are. Go to policies. In the policies, first we need to allow the GRE traffic. Okay. As of now, first we'll create a security policy so this GRE tunnel is established. So for that GRE tunnel to establish, we'll create a policy LAN zone to WAN zone 10.0.0.10 can go to 10 sorry 192.168.253.99 199. One policy should be this from LAN to WAN, and also this IP address 10.0.0.10 is natted to 192.168.253.210 on ETH 1 by 3 interface statically when it goes to this. So there is a static NAT for this IP address when it goes here. So I do not need the specific routing from R3 towards the firewall for this subnet. Now I'll create a rule which will allow the both directions of the traffic LAN to WAN as well as WAN to LAN. So let's look at the security policy for the GRE traffic. I've already created a policy. It's in disabled state. I'll just enable it. So this is the policy you need to create. You can see the policy name is GRE traffic, interzone, source, LAN zone, and WAN zone both. And the destination zones also LAN zone and WAN zone both. If you see when the traffic will go from LAN zone to the WAN zone, the source will be 10.0.0.10 and destination will be 192.168.253.199. And when the traffic will come reverse way, if the tunnel is initiated from R3 to R4, it depends which direction the tunnel is initiated and the packets are flowing. You need to allow both directions of the traffic. So if the traffic is coming from WAN zone and going to LAN zone, so router's IP address will be 199. That's this router. It will be the source, and then it will go towards the LAN zone, and LAN zone will be the destination zone. But as there is a NAT, you need to use a NAT IP here. So this is a destination NAT kind of a stuff. Okay, you use post NAT zone and you use pre-NAT IP. Okay, pre-NAT IP, post-NAT zone. So that's how this rule allows access and bidirectionally for the GRE traffic application. I have selected as GRE, and then nothing in service and URL category. Action is allowed. Now let's enable this rule. I'll enable it. Where is the enable button? Enable. Okay, the rule is now enabled. Let's enable the NAT rule as well. So the NAT rule for here is, this is the NAT rule. You see the original packet LAN zone to WAN zone going to ETH 1 by 3, 10.00.10 to 192.168.253.199. Translated packet, you do a static NAT with this IP and it is bidirectional. So as we saw in the NAT lectures, I have already explained how this bidirectional stuff works. So you can refer that lecture to understand how the translation will be happening here. Now let's enable this rule as well. Enable. Now as soon as I commit the change, my NAT policy along with my second service, yeah, I'll close. My NAT policy and my security policy will come alive, and the traffic will start flow between R4 and R3. The GRE tunnel will be established and these PCs will be able to communicate with each other. These PCs will be able to communicate with each other, but my firewall will only see the source and destination as 10.00.10 and 192.168.253.199. So that's how the GRE works. So how GRE does, it takes the IP packet, over that it puts the GRE header, and on that GRE header there is another IP header which is put in case of GRE. So firewall will only see the outermost IP header. It will not be able to look what is the data inside the GRE header. And the tunnel inspection policy helps us to look inside the uh, data which is inside the GRE header basically. So any unencrypted tunnel can be inspected by the Palo Alto firewall. As of now, I'll see if my commit is complete or not. Let me see quickly. Yeah, commit is still not complete. So I'll pause the video and I'll wait for the commit to complete. The job ID 775 of commit is now complete. Let's try to ping between VPC5 and VPC6. So VPC6 will be pinging VPC5. One second. Yes. Destination host unreachable. Okay, let me try from here. Aha, I put the wrong IP address is in place. One second. It should be 172. You can see it can ping. Now from here, let me put ping 172.16.10.10. It should be pinging. Okay. So you can see it can ping VPC5 can ping VPC6 and VPC6 can ping VPC5. Now let's look at the log on the Palo Alto firewall. Go to monitor, go to traffic. So these are not the logs we are looking for. This is some drop log. I'm gonna leave it here. Yeah, you can see we are not seeing any log other than this GRE one. There is a GRE log, and I'll show you also the session will be there, but only for the GRE. You can see LAN zone to WAN zone, traffic went and GRE. So our firewall right now cannot see the traffic what is inside the GRE. GRE is basically a tunnel protocol. It encapsulates the IP packet inside it. So our firewall right now is not able to see the packet inside the GRE. I'll just wait for it to pop up again. Yep. So now let's make our firewall have a look inside the GRE packet. For that, we need to create a tunnel inspection policy. So I'll go under tunnel inspection. I have already created a policy. I'll just show you there. So you can see, give it a name, source. I would say LAN zone when this source is going to WAN zone and this destination. Inspect what tunnel protocol you want to inspect. I want to inspect GRE. There are certain more options. GPRS tunneling protocol, non-encrypted IPsec, and the VXLAN as well you can inspect. And then the inspection options you have only on one level of inspection should be done, once inside the tunnel it should be looked. If there is tunnel in tunnel, then you need to select the two levels. So drop the packet if over maximum tunnel inspection level, Drop packet if unknown protocol inside the tunnel. We have selected GRE, so if inside the tunnel there is a protocol which firewall cannot understand, it will drop the packet. Drop packet if tunnel protocol fails a strict header check, there will be header checks, and return scan VXLAN tunnel to the source. It's a VXLAN specific traffic. Sorry, basically setting. Security options. Now you need to assign a zone to the traffic going from one side to other. So these zones are of type tunnel. So you create two tunnel. I have created two tunnel type zones. So I am assigning tunnel source zone. So whenever the source is this, if source is this, then whatever is the source IP, it will be inside the tunnel. It will be assigned to this zone. Whatever is the destination IP and inside the tunnel, that will be assigned to TWAN zone. Tunnel ID, no, it's only specific for VXLAN. That's it. I have created this policy. Let's enable this policy. If we enable this policy, now my firewall is going to look inside the tunnel and going to apply the security policy on it. So in the security policy, I need to also allow the respective traffic. So I have created this rule for this. Let's enable that. It says from the TLAN zone, which is for tunnel zone, to the TWAN zone, allow all the traffic application allow. Now let's commit the changes. And while the changes are getting committed, I will show you the zones created. So go to network, zones, and it is a TLAN zone. If I click on the TLAN zone, you can see TLAN zone type is tunnel. Once it is tunnel, you cannot assign any interface to it because it is then used in the tunnel inspection policy. Right now, my commit operation is in progress. So I'll pause the video while the commit completes. Our commit is now complete. And let's have a look if the access is working or not. So VPC6 should be able to ping VPC5, pinging. VPC5 should be able to ping VPC6, yes. But now let's look at the logs. What's the difference in the logs we are seeing on the firewall? Let me just reload them. Okay, it hasn't come yet. I'm just waiting for it to pop up. Okay, while the logs are coming, I'll explain something in here. If you see in the wireshark, this was the packet structure. This is the packet structure of the GRE. If you see previously, our firewall was taking decision on this header. Okay, in this way, it was seeing this header. It was not looking for the data inside the GRE packet. But after the tunnel inspection, it will take the decision on these IPs and not on these IPs. These will be there, but only for the GRE. But really, the firewall is going to open the packet after we configure the tunnel inspection, and it's going to see these headers and apply the security policies on this traffic as well. So let me pause the video and look for the logs, and I'll come back again. Everyone, so I have sorted out why I was not able to see the logs. The thing is, I was inspecting only one direction of the tunnel, but not the other direction of the tunnel. So I needed to put another rule, to do the other way tunnel inspection, which is from this R3 to R4. I already have R4 to R3, so I set it up that. And in that, I used as we put a security rule. Similarly, for the tunnel inspection, I use postnet zone and the prenet IP address, and rest of the settings are same as this. And there we go. I have the beautiful logs in there. So I can clearly see 1070 172.16.20.10 going to 10.10. That is TLAN to TWAN. It was allowed. My firewall looked inside the GRE packet and then took action on the inside header. And TWAN to TLAN was denied because I do not have a security policy for it. Yep, you can see in my GRE inspect, I only allowed LAN to WAN. So the traffic which is initiated from VPC5 can go to VPC6, but VPC6 cannot ping to VPC5. So let's see if VPC5 can go to VPC6. Yes, it can go, but can VPC6 come to VPC5? It shouldn't be a case because, yeah, the TWAN to TLAN is not allowed. Let's have a quick look at the monitor tab. I should refresh the logs. This is already a drop log to show you the stuff. So yeah, you can see again drop TWAN to TLAN, but TLAN to TWAN is allowed. So that's it for this video. Thank you for your time. Have a good day.